All right, here's our second video from section 5.7 on solving by factoring. We looked at example number 1 where all of our polynomials were already factored. Now let's start from scratch. Let's start at step number 1 and let's solve by factoring all the way through. So looking at example number 2, it asks us to solve by factoring, not just factor, but solve by factoring. So we need to go all the way down and make sure that we have answers that say x equals. Okay, so let's follow the 8 steps now in factoring. The first one is making sure everything's in order and all to the same side of the equal to sign, which it is on this one. Then make sure to look for a GCF. On A, there is no GCF. Then let's look to see how many terms there are. In this one, I noticed that there's 3 terms. This is either going to be a basic factor or a bottoms up. This one's going to be a basic factor. So let's figure out what numbers multiply to 6 that add to give us 5. You should be able to factor this into 2 polynomials, x plus 2 and x plus 3. Now that I have my problem factored into 2 binomials, I have 2 polynomials multiplied set equal to 0. I can now solve by setting each of those factors equal to 0. I can set my x plus 2 equal to 0, and I can set my x plus 3 equal to 0. I can subtract 2 and get x equals negative 2, and I can subtract 3 and get x equals negative 3. So I end up with 2 answers, x equals negative 2 and x equals negative 3. If I were thinking about this graphically, what would it look like? Well, I know now it's going to touch on the x-axis at x equals negative 2 and x equals negative 3, and it's going to be a parabola looking something like that. Maybe not exactly, but maybe something like that. Let's look at B. B looks a little bit different. B is in order. Is there a GCF? Ooh, so did you take out that GCF first? So I noticed that both terms had an x in there, so I factored out an x, leaving me with a binomial of x plus 7. Now that I'm done factoring and I have 2 polynomials being multiplied and they're set equal to 0, I should be able to take each of these polynomials and set them equal to 0 in order to solve. So I'm going to set the first one equal to 0, that's x equals 0, and then x plus 7 equal to 0. I can add 7 or subtract 7 from both sides, and I get 2 answers, x equals 0 and x equals negative 7. You notice that I had 2 answers on both of these, right? Well, if I look at the degree of my polynomial, that helps me figure out how many solutions I'm going to have. So when it has an x squared and my degree is 2, then I know that I'm going to have 2 solutions. So that helps me make sure that I haven't missed anything. On the first one, I had an x squared, so I knew that I was going to have 2 solutions, and I make sure that I didn't miss anything. Let's do a few more. On C, this one looks like it is in order, but if you notice that the equal to sign is kind of smushed in between everything, right? And our first step is not only to put it in order, but make sure that everything's over to the same side of the equal to sign. So I want to go ahead and take that negative 16 and I want to move it over. I'm going to move it over by adding 16 to both sides, and I end up getting an equation that looks like this now. I have an x squared minus 8x plus 16 equal to 0. Now that everything's over to the same side and equal to 0, and it's in order, I can now do my factoring. There is no GCF, and it looks like there's 3 terms. It looks like this is going to be a basic factor problem. So what numbers multiply to 16 that add to negative 8? Well, I ended up getting negative 4 and negative 4. So I factored it into x minus 4 and x minus 4, set equal to 0. I have those 2 binomials that are being multiplied, set equal to 0. So I can set each one equal to 0 and solve. So I get x equals 4 and x equals 4. Now what would that look like, you think, if we went and graphed that quadratic? Well, it looks like it touches at x equals 4, and so it looks like maybe just the vertex is going to touch on the x-axis at 4, because it really only touches the one time. Now, some of you might say that's one answer, but technically that's just a repetition of the same answer, but technically still 2 answers. Just happens to be the same answer. All right, let's look at D. D has a 4t squared equal to 0. You notice that our equal to sign is in the middle of everything, so let's go ahead and move that 25 over. I'm going to move the 25 over by subtracting, and I ended up getting 4t squared minus 25 equals 0. I'm going to look for a GCF, which I don't think there is one, and then I'm going to try to factor. It looks like on this one I have 2 terms. And remember, when we're following our steps for factoring, if there's 2 terms, this is either going to be a difference of squares or hopefully a cubes factoring problem. Let's try squares first. So is there a perfect square for 4t squared? Can I break that up equally? And is there a perfect square for 25? Sure, so I should be able to factor this into two conjugate binomials. So I factored it into a 2t minus 5 and a 2t plus 5. Now that I have both binomials multiplied together set equal to 0, I've factored completely, I can go ahead and set each factor equal to 0 and solve. I can add 5 to both sides, divide by 2, and I end up getting t equals 5 halves. On the other one, I can subtract 5 from both sides and divide by 2, and I end up getting x equals, or t equals, negative 5 halves. I end up getting 2 answers because my degree is 2. All right, let's do 2 more here. Look at E with me. Is it in order, all to the same side? Looks like it. Is there a GCF? Ooh, it looks like on this one I can GCF out a 2, right? So I'm going to GCF out a 2. That leaves me with a trinomial of 2x squared plus 5x plus 2. Now that I've looked for a GCF, it looks like the remaining polynomial has 3 terms and a number in front other than 1. So it looks like this is going to be a bottoms up problem. Do you remember the steps for bottoms up? My friend doesn't read books. Here we go. Let's multiply the 2 times the 2. Let's factor into an x plus 4 and an x plus 1. Let's go back and divide by whatever we multiplied by in the first place, so that's 2. Let's reduce, and let's bring the bottoms up. So I end up with a 2, an x plus 2, and a 2x plus 1 are my 3 factors. Now that I'm done factoring, I should be able to take each piece and set it equal to 0. When I put the 2 equal to 0, 2 equal to 0 just kind of goes away. There is no answer for that piece. There's no variable in that part that adds to my solutions. I have an x minus 2 after I set it equal to 0 and solved, and I get an x equals negative 1/2. I still end up getting 2 solutions, x equals negative 2 and x equals negative 1/2, using my bottoms up. All right, look at F. Is it in order, all to the same side? Ooh, let's move that 9x squared over and let's put it in order first. So I'm going to subtract 9x squared to both sides, write it in order, and I end up getting a polynomial of 3x cubed minus 9x squared minus 30x equal to 0. Now let's follow our steps for factoring. Look for a GCF. Ooh, I noticed that I can take out a 3 and an x. That left me with an x squared minus 3x minus 10. Can we factor more though? That leftover polynomial looks like there's 3 terms in here, so let's try to basic factor. What number is multiplied in negative 10 that when you add them together you get negative 3? I got negative 5 and positive 2. So now I have 3 factors, 3x, x minus 5, and x plus 2, that I have factored set equal to 0. So I can take each piece and set it equal to 0 and figure out what x is. Now before we solve, how many answers do you think we should have on this one? This one's a little bit different, isn't it? Because my highest degree now is 3, so hopefully I have 3 solutions this time. Let's see. When I set the 3x equal to 0 and I divide both sides by 3, I ended up getting x equals 0. That's one solution. When I set x minus 5 equal to 0 and I added 5 to both sides, I get x equals positive 5. That's a solution. And when I set the x plus 2 equal to 0 and I subtracted 2 to both sides, I ended up getting x equals negative 2. So I end up getting 3 solutions, which is what I was supposed to have at the beginning, right? So that's a quick, easy way to double check that you haven't missed anything. All different types of factoring is really important, and now we're going to add one more step onto it. Anytime it asks us to solve, after we're done factoring, we've got to set each factor equal to 0 so we can get all the solutions that we need. Keep practicing.